Today we are going to plot the meta-regression results as a bubble plot. And a bubble plot is a fairly conventional way to display the outcome of a meta-regression, which is just like a regression, but for synthesis stuff, where we plot a predictor, a continuous predictor, against the effect sizes, and then we fit a slope trying to estimate the relationship between the two. This is not too different from classic regression, but with meta-analysis and meta-regression models, we do have additional layers of variability that we model in. And so you can't really use canned software for the plotting because it wants to fit. They would typically want to fit their own lines, especially in Excel. But we estimated our own slopes and intercepts using a meta-regression model. And so the point of the video today is to do the bubble plot with our own regression coefficients that we estimated from the meta-analysis model. This is not stuff that Excel does by itself. In a previous video, I show you guys how to do all the estimation for the meta-regression coefficients for both a fixed and a random effects model. Check those out. We're going to recycle those numbers here for the bubble plot. And it should be fairly straightforward to generate a nice looking bubble plot in Excel, just because it already has a bubble plot feature. But again, it's the line that's hard. We got to stick in our own lines because Excel does not estimate that kind of stuff. All right, so let's jump into Excel. The data set we're going to use is from the Kolditz et al. 1994 JAMA paper of vaccine effectiveness in tuberculosis. And it's kind of a classic paper used to teach a meta-regression because it has a strong latitudinal moderator of the effect sizes, where, you know, further away you go from the equator, the better the vaccine works. And check out the previous video on meta-regression where I kind of analyzed that data set to estimate the regression coefficients. But I have these plotted right here for you right now in Excel. We got our random effects meta-regression. We got our estimated intercept, estimated slope. We got all the goodies associated with that, which we're not really going to make use for plotting. But the things we do need for the plotting is the variance-covariance matrix of the regression coefficients. That's not something you typically have access to, but because we actually modeled it explicitly using matrix algebra, we have access to it, which will allow us to estimate these bands around the slope. But no worries. Everything I'm going to show you how to do today, you could do the bubble plot and the regression line, but if you want to do those confidence intervals around the line, you need this variance-covariance matrix of the regression coefficients. Feel free to check my other video out. I'll show you guys how to estimate that. I wish it was straightforward, but it's not. You know, doing matrix algebra in Excel, woo! It's quite the endeavor. But don't worry, I got your back. And so check that video out and come back here, and then I'll show you guys how to plot that stuff. But if you're ready, if you're primed for it, let's jump into it. So here's our data set where we have our x-axis values here, which is the absolute latitude. We have our log risk ratios, which are on the y-axis. We're not going to follow exactly what this plot is because it's for some reason uses a log axis. We're going to ignore the log axis. It's totally unnecessary. But we're going to try to replicate this. So we're going to have the little bubbles of different sizes. The bubbles of different sizes is meant to provide a visualization of the weighting involved in our meta-regression. Studies emphasized with a large bubble are the studies that contributed more weight in the overall analysis. Things with a little bubble are those that emphasize a little fraction of a weight. Okay? And so what will happen is you see the meta-regression line kind of follows heavily the big bubbled studies and not so much the little bubble studies, because they don't contribute much in our estimation of that line. That's the beauty of meta-analysis and meta-regression, is we weight studies by sampling error, and which means not all data points are treated equally. We provide more emphasis on those where we have more evidence. That's really a hallmark of meta-analysis. Okay, so the goal now, we're going to do this in 3 steps. One, we're going to first create the size of the bubbles, because we want them to reflect the overall weighting in our meta-regression. Then we're going to fit our meta-regression slope, and then we're going to fit the confidence intervals around that slope. So first things first is we want the bubble size. And the bubble size is going to be related to the inverse of the square root of our variances. Right, so the weight of each study in our meta-regression is the inverse of the variance. But now we're going to do the inverse square root, because we want to further emphasize the weighting, the disparity in weighting between studies. It's just a visualization trick. However, it means that our bubble size are no longer empirically providing information. Now they are just providing a visualization of overall weighting. They are not representing the weights. That's kind of the goofy part of the bubble plot is, ideally the bubble size would reflect the actual weights, provide empirical information, but we need to exaggerate those. Otherwise, you won't see the difference between the study weighting. It's just one of these tricks to just kind of get the bubbles to pop out. Since you could see, oh boy, okay, that study right there is weighted heavily relative to the other ones. All right, excuse me. So let's throw in a bubble plot. And add some data to it. Here we go, select data. Add, we'll call this bubbles. We want our x-axis data, which is here the absolute latitude. We want our y-axis data, which is our log risk ratio effect sizes. And then finally, we want our bubble sizes, which we calculated already, which is the inverse square root of the variances. And then, okay, boop. There we go. We got our first bubble plot. It does not look at all the same as what we got pictured here. We need to tweak it a little bit to get it to start looking like this. First things first, I'm just going to erase some of these embellishments that Excel likes to add. Then I need to move the x-axis, which here is positioned at the 0 mark, which is totally fine, but it's not the typical way in which you plot bivariate data. That's Excel idiosyncratic. I can't say that word. It's idiosyncratic Excel, and so we need to fix it. And here we'll do the format access, and then we want them to plot it at the bottom, and so we're going to say -2 here, and that should shove the x-axis at the bottom of our plot. There we go. While we're at it, we might as well add figure captions. This will be called the log risk ratio, and this one will be called absolute latitude. I'm just going to modify the font here to make those pop out. And then finally the same for the y-axis caption. Okay, so we're getting there. Next thing to do is to add this null axis here. And the null axis on this plot is different because we're on a log scale, but we're going to ignore the log scale here because it's totally unnecessary. Our null is going to be 0. And so what we need to do is just create a null column with a bunch of zeros. And what that will do is we're going to use it to plot just a null line, but we'll get to that later. Okay, next thing to do is slightly modify these bubbles here. They're too big. And so we're going to, the size will represent the width of the bubble, and then we want to scale down to about 25% of the width, just so that we can mimic what's plotted over here. And you can see it's basically what we got. Now there's slight differences in axes, right? So here the plot ranges from 10 to 60. Or here it starts at 0, so we could quickly modify that to replicate the bounds of the graph. Okay, and so next thing to do is just add little tick marks. Oh no. Tick marks, we want major on the outside. And then we want more majors on the outside for the y-axis. Okay, we're getting there. The next step is to actually put that line, this meta-regression line. Now, Excel, it wants to fit its own line to these data, but we do not want that. They will not be properly estimated. We did a meta-regression, and so we want to put our own slope. And so this is kind of where it gets a little goofy, in that we have to generate some predicted values in order to trick Excel to plot all these lines. And so the first thing I'm going to do is, because the range of the x-axis is from 10 to 60, we're going to create a range of values that span that entire range from 10, 20, 30, 40, 50, 60. Those will be our benchmarks for plotting on the graph. Because we need to trick Excel, and we're going to use some matrix algebra to do that, I'm going to add a column of ones. This is going to be essentially be called a design matrix, which is useful for plotting the confidence intervals around our plot. The next step is to, again, we always need to trick Excel. Okay, so we need another column that specifies the size of the bubbles. And we're always going to have, these are just a random number that I stuck in that's big. And so when they plot these values down, the bubbles will be big, and then we could edit it to remove them later. It'll make more sense once I start doing that stuff. This is all just part of the trickeries involved in trying to bamboozle Excel into doing a bubble plot. Okay, the next thing is to actually start calculating our predictors. So we're going to call this pred, and then we're going to call this lower confidence interval, and this one will be called upper confidence interval. And we are going to estimate these using our slopes and intercepts from our meta-regression model. And we're going to use a little bit of matrix algebra here to get that done. And so first things first is we're going to estimate our predictors. And the predictor here, which will be our slope line, is essentially just going to be our slope and intercept multiplied by our design matrix. At least individual rows in our design matrix. It seems like a mess, but this is really meant to make it easier for you in the long run in terms of plotting this stuff. Okay, so the matrix algebra equation for this is mm mult, right? We're doing a matrix multiplication. We're going to multiply our design matrix, one row of our design matrix, and then we're going to multiply it by our regression coefficients, which are these betas that were extracted from the meta-regression, estimated from the meta-regression model. Now, we always want to use those regression coefficients, and so I'm going to fix them using the $sign here. And so what's this going to do is going to grab the regression coefficients and multiply it next to this design matrix parameter. For matrix algebra to work in Excel, you need to do Control-Shift-Enter. Okay, any matrix equation you throw in there, or matrix function, you need to do Control-Shift-Enter. Otherwise, nothing's going to work. It's just, again, one of these idiosyncratic ways in which Excel describes or allows you to model things with matrix algebra. So I'm going to do Control-Shift-Enter now. And this is going to be our first slope prediction at the 10 latitude part. Okay? And okay, so then, the next thing is to drag down these to get the other estimates for the other levels of latitude. So this essentially becomes our slope line. This line right here, that's our slope line. Okay, we just had to hard code it in Excel. And what we're going to do is plot these points as bubbles. Then we're going to fit a line to those points. I know, this kind of like weird acrobatics to get what we want. And then we're going to hide the bubbles so that the only thing that's plotted is the line. Okay, so let's add our regression slope to this plot. So we're going to select some data. We're going to call this slope. We got our x values, which are in our design matrix. We got our y values, which we just predicted. And finally, we're going to use our generic bubble plot points, which are all the same. And there we go. We got these orange things plotted here. Let me make this bigger so you can see. Right, so you got this orange line right here that's fitted. We're going to fit a line to that now. A trend line as a linear prediction, right? And that is how you plot your regression slope. Well, now we're just going to edit that line to make it look cool. Right, so we are just going to modify the color. We want it to be like a chunky line. We want it solid. Solid and black is good. Next thing we want to do is just hide our little bubbles. So no fill, no border, and that hides the bubbles. Whew. Okay, now we're going to do that again for the confidence intervals, but we have to use a slightly different equation to estimate those in our prediction table. Okay, so we'll start with the lower confidence interval, and here we're going to use the variance covariance matrix of our regression equations. I'm just going to move this over a bit. And first things first, we have to calculate the standard deviations for each of our predictor slope variables. Okay, and this is where we're going to use a little bit more matrix algebra to get these done. And so the goal here will be to again use our design matrix. We will multiply that by our variance covariance matrix, and then multiply it again by our design matrix. And what that's going to do is collapse our variance covariance matrix into a single value, which will be the standard deviation of the slope, which we could use for the lower confidence interval. All right, let's just get it done, because this is kind of the ugly part. We want to multiply again, mult. We want to first multiply our design matrix. We want to multiply it now by our variance covariance matrix, which is this little guy right here. And again, we want to fix that so it doesn't change when we scroll it over to other elements in the spreadsheet. Finally, we want to multiply this by, again, the transpose of our design matrix. Okay, so this will, again, create the regression variance associated with the coefficient. I need to do a Control-Shift-Enter, otherwise it will not do any of the matrix calculations. All right, there we go. So we got our standard deviations. I'm going to calculate it for our other predictors. We're almost done, basically. And there isn't really much more left other than calculating the confidence intervals and then making the plot look nice. I'm just double checking with my reference data set to see if we got things similarly. And we do. Okay. Okay, I need to move on. This is taking way too long. Okay, confidence intervals. This is I'm going to put the equation here for you. Basically, we want our predictor minus the inverse of the normal distribution function times the standard deviation. I mean, it's ugly, but you know, this is what we got to do to trick Excel. So let's just get it done. We got our predictor, because we're doing a lower confidence interval. We're subtracting it from the model. We're going to do the norm inverse, which returns the normal cumulative distribution function. Whew. We want, this is where it gets a little funny. It's a two-tailed distribution, so we have to subtract at the 0.05 level. This is stuff you don't really need to know of. And of course, because it's the normal cumulative distribution function, we're going to set it at a mean of 0 and a standard deviation of 1. And finally, we're going to multiply that by our standard deviations, which is the square root of the variances that we calculated. All right, now do the same thing for the upper, but we need to add it. All right, so we got our upper and lower confidence intervals. We're going to quickly add these to the plot now. We're going to select data. We're going to add lower CI. X values are what we set up already. Y values will be the lower confidence intervals. And then finally, the bubble size will be just this random bubble size that we set up earlier. Okay, we got those set up. They're kind of light gray right now. Now we're going to fit a trend line to these points, and we're going to use a polynomial to fit the line there because the line is curved. All right, so the next thing is to do the upper confidence intervals. Select our data again, add UCI. Let me cancel this because this plot's in the way. It's one of these things I detest about Excel is that the plots always just like are always in the way. You should make them transparent so we can see what we're doing on the spreadsheet. Okay. Select data, add UCI for upper confidence intervals. We got our x-axis. We got our y-axis. We got our bubbles. And they're orange. Again, we're going to fit a polynomial trend line because the confidence intervals are curved a bit. And now the next step is just kind of hide those values. All right, it's not letting me quickly grab those points, and so I'm going to trick it into being a larger size here so that I could click on them. And we're going to format them, and we're just going to make them disappear. No fill, no line. No fill, no line. And then while we're here, we could make the lines chunky. I kind of like the light gray colored. Like that. And then finally, let's just change the color to the circles too. I am going to make those circles white with a chunky border. It's my own preference. We'll make those black. There we go. Well, there you have it. There's your meta-regression bubble plot. There's certainly a few things we could fix here. Excel likes to just kind of add things. Makes things look silly. We just have one more thing to add to this, and it's the null line. And the null is going to be 0, so we're just going to throw them over here and quickly add some data to it. We got our x-axis points. We got our nulls. We got our bubble sizes. right? So it's going to, like a straight line here, we're going to fit another trend line. And then we're going to hide the bubbles. And there you have it. Oh boy, we got our bubble plot. It is essentially the same as what we got. I kind of modified some of the embellishments. The circles are a bit bigger on the Excel plot. Again, you could just adjust the relative size of each of these things. But everything we need is here. You can feel free to add this plot and make it look nice and do all those embellishments. Again, that just to emphasize is it's not easy to do this in Excel because there's no way to do like a weighted regression analysis in Excel, or in particular a random effects meta-analysis or meta-regression in Excel. And so feel free to check out my previous video to estimate those things, and then we could build the bubble plot. So hopefully this video was useful for you. If you like it, that's cool. I will probably do more of these Excel videos in the future. Again, everything relating to research synthesis, friends. All right, I'm done for today. Take it easy.